Good morning to Dr. Un. We are from Group 1 and today we would like to present to you our group's project on the golden ratio and how it will be related to mathematics. So for today's agenda, we have divided the application to three subtopics: golden ratio in arts, music, and architecture. Here's the brief introduction about the golden ratio. Mathematics beauty is an advanced form of beauty. We know that mathematics is a language and there's many things in our daily life we could relate it to mathematics. So golden ratio is one of them. In mathematics, two quantities are in the golden ratio if their ratio is the same as the ratio of their sum to the larger of the two quantities. So that is how it will be expressed algebraically. Like in the blue figure, a plus b over a equal to a over b, and it is equal to 1.618 and so on. So that is the Greek letter phi represents the golden ratio and it is an irrational number. Next, here's the first subtopic I would like to discuss today: golden ratio in arts. Golden ratio is used to define the horizon, and most of the famous paintings, such as Mona Lisa by Leonardo da Vinci, use the golden ratio to create the balance in their arts. And then, based on the figures, they all are the golden shapes. They are rectangle, spiral, circle, and triangle. So these golden shapes are used in painting. And the relation between these shapes and mathematics is all these are made from the horizontal and vertical lines that we all learned during our elementary school. Interesting, right?
Next, what is a golden spiral? This spiral-like form is said to be seen in numerous locations in nature and in art. For example, as the shape of the Nautilus shell, a galaxy, a cyclone, or even a wave. There are two issues here. To begin with, the form is not a spiral. It is a series of circular arcs. The spiral curvature changes as you move from one arc to another. Such leaps are extremely rare to occur in any natural phenomena. It is an example of logarithmic spiral since it approximates the shape of the spiral. The formula for a logarithmic spiral using polar coordinate is RT equal to A exponential power theta cotangent B. Golden spiral has the special property such that for every 1/4 turn, the distance from the center of the spiral increases by the golden ratio. The Mona Lisa, a well-known painting by Leonardo da Vinci, is drawn in accordance with the golden ratio. The golden ratio is 1:0.618 and has been dubbed so because it is visually appealing. The golden ratio may be found all over the human body. A golden rectangle is just a rectangle with a golden ratio dimension. Throughout the artwork of the Mona Lisa, there are several golden rectangles. We can observe that it is truly golden by drawing a rectangle around her face. If we split that rectangle by a line drawn across her eyes, we obtain another golden rectangle, indicate that her head length to eye length ratio is golden. Other golden rectangles can be drawn on her body, such as from her neck to the top of her hand. So, how exactly did Leonardo da Vinci use the golden spiral? First, he framed the Mona Lisa in the artwork with it. The spiral begins at her left wrist and goes to the image backdrop, which contrasts with the beauty of her face. It then grinds across her brow and turns till it touches her chin. It climbs past the tiniest of her dimples. Lastly, it completes one rotation, which ends at the tip of her nose.
I will be presenting on the golden ratio in music. When it comes to the golden ratio, it is necessary to talk about the Fibonacci sequence, which was developed by Leonardo Fibonacci, an Italian mathematician. One day, he was asked by someone on how many pairs of rabbits can be bred in a year if he initially had 2 pairs of rabbits. After some calculation, the answer to that question has caused the emergence of the wonderful Fibonacci sequence. This is the Fibonacci sequence. One of the things that make the Fibonacci sequence is so special is if we take any 2 adjacent numbers, the ratio of the first number to the second number is getting closer and closer to the golden section value of 0.618. In fact, the bigger the pair of Fibonacci numbers, the closer the approximation. In music, the Fibonacci sequence is also known as the golden section sequence. Many composers intentionally or unintentionally refer to the golden section in producing their music, which has become a magic weapon for their works to last forever. Here is the Stradivarius violins, which are famous for their tonal. The design of the violin follows the idea of golden section in the proportion of the neck, backbox, and scroll to the body of the violin. The subdivisions of the instruments, waist to the upper bout, waist and upper bout, to those sections plus the neck. All of these try to meet the golden ratio as much as possible. This latter has caused the music from a strat so rich and resonant.
Let us look at the examples. Firstly is the Mozart's Sonata in D major. Its first movement is 116 bars in length. If the number of bars is multiplied by the ratio of the golden section, the produced part of the piece is exactly in bar 99. That's just at the golden ratio points. Next is Bartok. In a large number of Bartok's works, the climax of the music happens to be at the golden section points. That is, the product of the total length of the music multiplied by 0.618 is the climax of the music. The total length of the movement is 89 bars. The golden section point is in the 55th bar. Finally is the Robert Alexander Schumann's Traumerei. In Traumerei, the whole song is divided into 6 sentences and 25 bars. Calculated according to the golden ratio, the climax of appear in the 14th bars, which is completed consistent with the actual situation.
Now I will continue with another part, which is the application of the golden ratio in the architecture. As an introduction, the Great Pyramid of Giza stands as the last monument of the 7 wonders of the ancient world. The Great Pyramid of Giza was built during the reign of Pharaoh Khufu in 2560 before century. The geometry of the Great Pyramid provides means of finding crucial ratios such as pi and the golden number phi due to some rather simple geometrical principles. Pi and phi are irrational numbers which have an infinite number of digits. It is an amazing achievement to encode the value of phi precisely into a large structure like the Great Pyramid of Giza. There are 2 main concepts being applied in the Pyramid of Giza. The first one is the Herodotus formula, which was reported by a Greek historian named Herodotus. It says that the height of the pyramid is the side of a square whose area equals the area of each of the 4 sides. This gives us the formula of h equal to yx, where y is the half of the pyramid base and x is the slant height of the pyramid. Now moving to other concept, which is the Kepler triangle. What is Kepler triangle? It is a right triangle with a base length of 1 and a hypotenuse of phi. We also can extract this triangle by using the Herodotus formula. By the Pythagorean theorem, we have the equation of phi squared equal to phi plus 1. Referring to the slide, we have stated the estimated dimension of the pyramid, which consists of the height, base length, slope, and slant height. However, it's hard to verify the dimension of the Great Pyramid of Giza with certainty due to the deterioration over time. By the dimension, we can conclude a few of the geometrical proportions of the pyramid. The first one is the relation between the surface of sides and the surface of the base. Here we can explain that the surface of the 4 sides divided by the surface of the base equals the famous golden number phi, which is one of the key principles of aesthetic and design. The second one is the relation between the slant height and the half of the base length. By dividing the slant height of the pyramid by the half of the base length, we get the golden number. The third one is squaring the circle. Let's see if we draw a square and a circle all together, where the circumference of the circles equals the perimeter of the square. Then, if we measure the radius of the circle, it will give us the height of the pyramid on this square. Therefore, the Great Pyramid contains both pi and phi.
Next, I will continue with Parthenon. First of all, Parthenon is the largest and most lavish temple in the powerful Greek city-state of Athens, which is constructed between 447 until 438 before century. It was the center of religious life in the height of the Delian League. In Parthenon's construction, golden ratio or golden rectangle can be found in many construction aspects, such as in the entablature, the columns, the overall structure, the interior chamber, and also in the floor plan of the Parthenon. The pattern is surrounded by columns, which the distance between columns and the width of the capitals of each creates yet another golden ratio property, which is the width of two capitals on the columns. Next, pattern's overall structure itself displays the golden proportion. These dimensions and proportions of the entablature and columns tie into an overall structure of design that creates the following golden ratios. First, the height of the pattern from the base of the second step to the top of its roof peak is a golden ratio to its width at the end of the entablature. Second, the base the entablature is at the golden ratio point of the height of the pattern. And third, the top of the frieze is at the golden ratio point of the distance from the base of the architrave to the pattern's height. In addition, the golden ratio also seems to appear in the pattern's floor plan. The interior wall between the two chambers is at the golden ratio point of the distance between the center points of the exterior columns on each end. The centers of the anterior columns and base of the statue of antenna are at the golden ratio points of the distance between the center points of the exterior columns on each side. The width of the entryway to the large chamber is a golden ratio of the distance between the outside of the outer walls of the interior chamber, and the interior of the large chamber is a golden rectangle when using the center of the entry wall as the rectangle's perimeter.
In conclusion, the golden ratio has contributed to many sectors in this world. There are few mathematical principles used, such as the Fibonacci sequence, Pythagoras theorem, and geometry. All these have been explained previously by each of our group members. Aside from that, the discovery of the golden ratio has shown how mathematics work as a language of beauty. Mathematical aesthetic pleasure typically derive from the abstractness, purity, simplicity, and orderliness of mathematics, which not everyone could understand. Finally, we hope that our presentation could somehow illustrate how mathematics brought an added value to our life. Last but not least, don't forget to appreciate mathematics. That's all from us. Thank you.